Find the force in member AC. In this problem, a truss is connected to a wall with a pin connection at point A and a roller connection at point D. The truss is loaded vertically downward at point C, and there is no force in member BC. The dimensions of the truss are provided where variable D is a finite length greater than 0. Also, there is no connection between diagonal members AC and BD. To solve this problem, we'll focus in on joint C and set the sum of the forces in the horizontal direction and the sum of the forces in the vertical direction both equal to 0. As is standard, the horizontal axis will be x and the vertical axis will be y. If we define angle ACD as theta and angle ACB as phi, then from trigonometry, theta equals the arctangent of 3/4 and phi equals the arctangent of 4/3, respectively, or 36.9 degrees and 53.1 degrees. Assuming all members are in tension, the sum of the forces in the x direction and the sum of the forces in the y direction are calculated as shown. For sake of convenience, the force in each member will be labeled by its connecting joints, and will represent the load with the letter L. Solving for the sum of the forces in the y direction, we learn the force in member AC equals 5/3 times the load, in tension. When reviewing the possible solutions, the answer is D. This solution was determined rather quickly because we were given that the force in member BC equals 0. If we did not know the force in member BC, then we'd be left with 2 equations and 3 unknown variables. To solve a linear system of equations, we'll need at least as many equations as unknown variables and a non-singular matrix A. Therefore, we'll next look at joint B. The angles theta and phi are again 36.9 degrees and 53.1 degrees. If all members are assumed to be in tension, the sum of the forces in the horizontal and vertical directions are written out. Combining the equations from joints B and C, we now have 4 equations and 5 unknown variables. These unknown variables represent the tensile forces in members AC, AB, BC, BD, and CD. Next, we'll look at joint A. Since joint A experiences vertical and horizontal reaction forces due to its pin connection, we'll solve for the horizontal force by setting the sum of the moments around joint D equal to 0. That horizontal force, FAX, equals 4/3 times the load, L. The vertical reaction force at joint A is determined by summing the forces in the vertical direction for the entire truss and setting that value equal to 0. The vertical reaction force at joint A equals the load, L. By knowing these reaction forces at joint A, we're ready to compute the member forces at joint A. As with joints B and C, the angles theta and phi are calculated to equal 36.9 degrees and 53.1 degrees. After solving for the forces in each direction, we now have a linear system of 6 equations and 6 variables, each variable representing a force in a member. If we plug in the values of theta and phi and the reaction forces at joint A, these 6 equations simplify to fit the form AX equals B, where the terms on the left-hand side are unknown and the terms on the right-hand side are the constants. Setting matrix A equal to the coefficients of each member force, vector x to the forces, and vector b to the constant values, we determine the truss is internally indeterminate because its member forces depend on each other, creating a circular solution. If all member forces are based on the tensile force in member BC, which would realistically range between 0 and the load, L, we could solve for any of the other 5 member forces using these equations. Since the original problem asked to solve for the force in member AC, and the force in member BC was identified as 0, the force in member AC equals 5/3 times the load in tension. And this is the same solution we arrived at previously.